All right, so looking at your test or some of these questions, so I'm about to go through 11 questions and they're going to cover the different triangle postulates and other attributes of triangles. So question number 1 says, which statement would be sufficient to prove that triangle XYZ is a right triangle? Well, we know that in order for something to be considered a right triangle, that means that it has to have a 90-degree angle in it. So if I look at answer choice A, it says XZ is equal to ZY. That has nothing to do with having a 90-degree angle. This is looking at line segments. So how long the sides of the triangle are doesn't prove whether or not it's a 90-degree angle, unless it had something to do with the Pythagorean theorem. Question B says the measure of angle X is 45 degrees. Well, that could be possible, and that means that there could be a 90-degree angle, but that doesn't really prove it. So B wouldn't work. C says XZ plus YZ is greater than or equal to XY. Again, that doesn't really give us much information as far as being having a 90-degree angle. And then D says the measure of angle X plus the measure of angle Y equals 90 degrees. That makes sense because let's say, for example, that angle Z is a 90-degree angle. So then angle Y plus angle Z, plus angle X. Hang on, I'm going to try to make my handwriting a little bit nicer. Okay, so angle Y plus angle X plus 90 equals 180 degrees because the sum of the angles in a triangle has to add up to 180 degrees. So if I'm going to solve this algebraically, I would subtract 90 degrees from both sides of the equation. So then I'm left with 90 on the right, and then over here on the left I have angle Y plus angle X. So it makes sense that the two acute angles inside of a right triangle have to have a sum of 90 degrees. That's why number 1 is correct, or number 1 is D. Number 2 says triangle ABC has vertices where A is at 1, 3, B is at 1, negative 1, and C is at negative 2, 1. All right, let me double check that I put those in the right spot. So we have 1, 3, 1, negative 1, and then negative 2, 1. Perfect. Okay, so we want to classify the triangle. So the way that you would classify this triangle is by looking at the length of the sides. So the easiest one to count would be side AB. So this is 1, 2, 3, 4. 4 units long. And then if we look at the other two sides of the triangle, it is slanted, so it's not as easy to count to figure out how long the sides would be. So what you could do is you could use the distance formula. So for example, if I'm going to use the distance formula and I'm going to look at point A right here, and I'm going to look at point C, those are the points that I'm going to use for the distance formula. So our distance formula is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's our distance formula, and that's available for you on the reference chart. So if I'm using the x, I'm finding the difference in the x coordinates, so I'm going to move my work over here so I have a little bit more space. So the difference in the x coordinates would be 1 minus negative 2, and when you're subtracting a negative, that becomes addition. So 1 plus 2 is 3, so that's going to be 3 squared, plus the difference in the y's. So 3 minus 1 is 2, so that would be 2 squared. So then we have 3 squared, which is 9, plus 2 squared, which is 4, so 9 plus 4 is 13. So then here I get that the distance between A and C is the square root of 13. Now I could plug that into the calculator and figure out what the square root would be, but for the purpose of this, I don't really need to do that. And now in blue, I'm going to find the distance between points B and C. So now I'm focusing on points B and C. So what I want to do is I want to find the difference in the x coordinates. So 1 minus negative 2. Again, when you're subtracting a negative, that's addition. So 1 plus 2 is 3. So that's going to be 3 squared plus negative 1 minus 1. When you're subtracting, that's going to become a negative. So that's negative 1 plus a negative 1, which is really just negative 2. So I'll go ahead and put that in parentheses, negative 2 squared. So when you square a negative number, that gives you a positive number, so that gives you the positive 4, because you're multiplying a negative times a negative. So then what do we see? We're doing, again, 9 plus 4, and that gives us 13. So if the distance between B and C is also the square root of 13, then the best way to classify this triangle would be an isosceles triangle, since at least 2 of the sides are congruent to each other. Alright, let's look at number 4. I'm not going to scroll down to number 3 just because of the way that I already took the picture. Number 4 says, complete the following congruency statement. So on number 4, you're trying to match up the letters correctly so that they correspond to triangle MOL. So let me try to explain how you would do this. So what you're going to do is you look at how you're starting with the letter M over here. So I'm going from M to O, right down here, and then from O to L. Alright, so what I did is I started from one corner, so I want to do the same, go in the same order, but looking at the triangle that includes the letter N in it. So it looks like I went from M to O, which is the hypotenuse, and then O to L, which is the leg that just has one tick mark. So I'm going to start with O right here to M, which is the hypotenuse, and then I'm going to go down this side because that has the one tick mark. So then the correct way to write the congruent triangle would be O, M, N. So that would complete the congruency statement. Alright, number 5 says triangle MPQ is congruent to triangle ABC. So notice how the triangle is reflected. They're not in the same orientation if you look at the order of the letters. So it says complete each statement. So we're asked to solve for x. Well, here, this side down here, MQ corresponds down here to AC. So what would I multiply 4 by to get 20? We would multiply by 5. So x has to be 5. Now, angle C, so I want you to notice the difference in the next two right here. Right here it says angle C is congruent to blank. And then notice here how there's that lowercase m and then the angle sign and then the letter B. That means the measure of angle B is equal to. So like that second one, the measure of angle B, that's asking for an actual number. The first one is asking for a letter. What is congruent to C? So if I look in the statement right here, the letter C is the last letter. So right here, the last letter is Q. So I would say angle C is congruent to angle Q. Now we have the measure of angle B. So what does angle B correspond to? Angle B is the letter in the middle, so it corresponds to angle P. And angle P is right here, and we don't have a number value for that, but we could solve because we know that the interior angles of a triangle have to add to a sum of 180 degrees. So I can subtract 87 from 180, and what do we get? 93. That means that the measure of angle B is 93 degrees. So notice how I'm writing a number instead of a letter. So the last one is similar to where it's asking for angle C. So like this one says, line segment QP is congruent to which line segment? So what you would do again is you're going to look at the order that the letters are written in. So QP, last letter to the middle letter. So right here, the last letter is C, the middle letter is B. So I would say that it's congruent to line segment CB. All right, let's look at questions 3 and 6. So question 3 says, in the diagram below, triangle ABC is congruent to triangle XYZ. Which two statements identify corresponding congruent parts for these triangles? So if we look at A, it says AB is congruent to XY. That one's true. And I know because I'm looking at the order of the letters that it's given to you. So right here, AB, the first two letters are congruent to XY, the first two letters. That works. And then next, when I look at angle C, which is the last letter, it says angle C is congruent to angle Y. Well, that doesn't match up because angle Y is in the middle, so A doesn't work. Then B says AB is congruent to YZ. Well, that doesn't work because we already know that AB has to go with XY. So let me put an X right there. And then we have BC is congruent to XY. That one also doesn't work because we already looked up here and we already know that XY has to go with AB. And then we have BC is congruent to YZ. So let me erase what I wrote so we can look at that. BC, right here from the middle letter to the last letter, is congruent to YZ, the middle letter to the last letter. That matches up. And then it says angle A is congruent to angle X. Here's angle A, the first letter, and angle X, the first letter. That works as well, so D is correct. Next one says, as shown in the diagram below, angle or line segment AC bisects angle BAD, and angle BCA is congruent to angle DCA. Which method could be used to prove that triangle ABC is congruent to triangle ADC? Okay, so we know that this line segment is bisecting BAD. That when you bisect something, that means it's cutting it directly in half. So that means this angle right here has to be congruent to this angle right here. So those are equal to each other. We also know that this line segment AC has to be equal to itself. So that's a side that is being shared by both of the triangles, so they have to be equal. Then it tells you right here the angle BCA, which is this angle right here. I'm going to do that in blue just so that we can see. This angle is congruent to angle DCA. Those are congruent to each other. All right, now we want to look at the triangle postulates. First, I want you to realize that C doesn't work at all. AAA is not a triangle congruency postulate. AAA tells you that triangles are similar, but not that they're congruent. So C automatically doesn't work. So now if we look at what's given, let me see if I can use the highlighter on this. Okay, so what do we start with first right here? Right here, first we have an angle. And then as I keep going, I see a side. And then I see another angle. That's my cat, if you can hear that. So angle, side, angle. That is answer choice D. Sorry guys, my cat is making a weird sound. Okay, so D is correct. Angle, side, angle. Because we're looking at an angle right here. We're looking at this side. And then these angles right here. All right, let's look at number 7. Number 7 says, in the diagram below of quadrilateral ABCD, with AB parallel to CD, and angle ABC is congruent to angle CDA, which method can be used to prove that triangle ABC is congruent to triangle CDA? Alright, I want you to also recognize here that answer choice B automatically doesn't work. Side-side angle is not one of the postulates because it doesn't work every time. So we can automatically eliminate B. Alright, now let's look at what's given. AB is parallel to CD, and you can show that something is parallel by giving it these arrow symbols. That shows that the sides are parallel to each other. And then it tells you angle ABC, which is this angle right here, is congruent. Let me do that in a different color because that kind of... So right here, this angle ABC is congruent to CDA. So if we know that the sides are parallel to each other, we can look at the alternate interior angles. So like right here, this angle is an alternate interior angle with this one right here. And then we have the side that they share. So like this side, AC, is shared by both of the triangles. So now we have enough information to go ahead and prove that these two triangles are congruent to each other. So let me highlight it again. So what do we start out with? We start out with, right here we have an angle, and then we go down this side, we end up with another angle, and then we go over here and we see that we're hitting a side. So that's why the correct answer would be angle, angle, side. Because we start right here at this angle, and then we go to this angle right here, and then we end up at this side. Alright, let's look at number 8. Number 8 says triangle RST and VSU are shown below. Given that angle R is congruent to angle V and RT is congruent to VU, which additional information is sufficient to prove that RS is congruent to SV? Alright, so let's look at the first one. A says that TS is congruent to SU. TS is congruent to SU. That would be right here. So we're saying that this side right here would be congruent right here to this side. And when you're first looking at it, that looks like it could be a good answer choice. However, the reason why that doesn't work is because then if we look at the information that's given, we have an angle, and then a side, and then another side. The reason why that doesn't work is because that postulate isn't a postulate that works every single time. It's called SSA. That is not a triangle congruency postulate. The way that I remember that that one doesn't work is because if you rearrange the letters, it makes a bad word. So I'll let you play with that so you can figure that out. Alright, so that is why A is not the correct answer. Alright, let's look at answer choice B. So B says VS is perpendicular to RU. Well, let's look at that. If this is perpendicular, it's creating a 90-degree angle right here and a 90-degree angle right here. Would that be sufficient enough to prove that our triangles are congruent to each other? So then we would start right here at an angle, and we go down this way, we see another angle, and then we go across and we see a side. So then you would ask yourself, is that a postulate? Angle, angle, side. Yes, that is. So B would be the correct answer. Let's look at C, just so that we can go through all the answer choices. So C says RS is congruent to SU. Well, if we look at that, that doesn't really make sense right here, down here. RS, it appears to be a little bit longer than this side, SU. And now you don't want to look at something and say, well, it looks like this. So if we look at the way that if we look at those two sides, the reason why it wouldn't match up is because then our sides would not be corresponding to each other. So for example, on this triangle we have an angle right here, and then right here we have a side, and then here we have another side, and I'm not going to put the S because basically it would bring you back to that postulate, which we just went over, and we said that that one isn't a postulate, so it doesn't work. All right. What letters did I think I had angle, angle, side. I didn't mean to erase that. All right, the last one says angle VUS right here is congruent to RST right here. And again, that one doesn't work because look, here we have angle, side, angle. That one doesn't match up over here because on the other triangle we have right here an angle, and then a side. So those don't match up correctly. That's why B is the correct answer choice, because whenever you create the perpendicular sides right here, it gives you angle, angle, side correctly in the right order on both triangles. All right, let's look at number 9. Number 9 says A is the midpoint of MT, and the measure of angle SAT is 90 degrees. So we're going to, oh wow, it doesn't even, well, okay. There's no specific question here, but basically it's saying triangle SAT is congruent to triangle blank. So you're supposed to fill in that congruency statement by stating which postulate would make it work. So by definition of the midpoint, that means that this side is being directly cut in half. So MT is directly cut in half, so those sides are congruent to each other. And now if we know that the measure of SAT is 90 degrees, right here we can draw our little 90-degree symbol. Because it's a linear pair, the 90-degree symbol would also go over here. So let's go ahead and write what the triangle is congruent to each other. So SAT would match up with SAM if you set up the order correctly. And then by which postulate? Well, here we could actually put two answers here. So let me go over one of them. One of them would be that we could say, well, this angle matches, this side has to be congruent to the other triangle because they share the side, so those are equal. And then we have a 90-degree angle, and then we have the two sides that are congruent to each other. So that would be side, angle, side. Let me try to write that a little bit nicer. Side, angle, side. Now the other way, you could argue that you could use side, side, side as the answer, because here, if we know that we have a 90-degree angle, then we know that we could use the Pythagorean theorem. And the two legs are congruent to each other. So if we know the two legs, we could solve for the hypotenuse. And this hypotenuse has to be congruent to this hypotenuse because the legs are the same length. So you could argue that side, side, side would also be an answer choice that you could put there. Number 10 says, in the given diagram, are the two triangles congruent? If so, which justification would prove it? So if we look at the first one, what information is given to us? We have an angle first. Actually, I'm going to start out with the side. Okay, so here we have a side going to another side, and then finishing off right here at an angle. Well, we've talked about this one several times. That one is not a postulate. So we're going to say no. And actually, it's really not that they're not congruent. It's more of there's not enough information to prove that they are congruent to each other. All right, let's look at the next one. The next one, we have a pair of vertical angles right here. So the only information that we see are the 3 angles inside of the triangle. So we can see that the angles in both of these triangles are congruent. Well, that's not enough information. So again, we don't know that they are congruent or not, but really that's not enough information to tell. AAA just tells you that the triangles are similar to each other. There's a difference between similarity and congruent. Congruent means exactly the same size. All right, the last one we have right here, they have a side in common, another side, and then this side has to be the same because it's shared by both of the triangles. So this one for sure would work because it has the 3 sides that are congruent to each other. So that one is yes by side, side, side. And last we have question 11. It says given line segment FE is parallel to HG. So I'm going to draw my little arrow symbols right here to show that they're parallel. J is the midpoint of FG. Okay, so if it's the midpoint, that means that this line segment is going to be cut in half right here. All right, so on this one, we're trying to do a proof, and this is really an informal proof. I just want you to kind of go through your thought process to determine whether or not these 2 triangles are congruent to each other. So what I go through when I'm writing this down, it's just one possible way that you could prove that these 2 triangles are congruent to each other. So I could start out by saying that line segment FJ is congruent to line segment GJ. And I know that because if J is the midpoint, then that's what has to happen, because the definition of a midpoint is that you're cutting something directly in half because you're finding the middle. So I would put by definition of a midpoint. All right. Now, another thing that we could show here is that we have these vertical angles right here. So we have 2 vertical angles. So we can say angle EJF is congruent to angle HJG. EJF, HJG. All right, so they're congruent to each other because they are vertical angles. So you could say by definition of vertical angles. I'm just going to put A and G because I don't have enough space to write it out. Okay, what else do we know? We know that the 2 sides are parallel to each other. So what does that mean? it means that we could essentially look at line segment EH as being a transversal. And that means that we're going to see some angles that are going to be congruent. So right here we could say this angle is congruent to this angle because they would be alternate interior angles. So I'm going to say angle JEF is congruent to angle JHG. Definition of alternate interior angles. I'm doing a lot of abbreviation here since I don't have a lot of space. Okay, so with those three statements, now I have enough information to prove that the triangles are congruent to each other. So my last step would be to prove that they're congruent. So I'm going to say triangle JEF is congruent to triangle JHG by which postulate? So here, if we start by looking at the red right here, we have an angle, and then right here at the last part we have a side. So I would say by the angle side postulate. Now that's just one way. Okay, I realize that this is a super long video, so if you want to stop it there, I totally understand. But I'm going to go through and show you another way that you could solve. There was another postulate. Maybe not. I don't remember how it was. Okay. Well, I hope that was helpful for you guys. Have an awesome day.